In this next set of problems, we're going to learn how to balance redox reactions by using half reactions. Let's take a look at the first example. We have iron 2 plus cesium 4 plus gives me iron 3 plus cesium 3 plus. I have an exchange of electrons here, and I can look at individually at the ions, and for example, I can look at iron here, and then I can look at cesium separately, and those are my half reactions. So let's take a look at iron first. So I have iron 2 plus going to iron 3 plus. We said earlier that if I have an ion or an element that is actually becoming more positive, that means that it's losing negative charge, which means it's being oxidized. It's actually giving up electrons. And therefore, iron in this case is going from a 2 plus to a 3 plus. It's becoming more positive. It's losing electrons. Anytime you lose electrons, and it's only losing one, going from 2 plus to 3 plus, if you're losing electrons, those are going to appear on the product side. So plus an electron. Once you've written the electron in, you have to go back and make sure that the charges match. On one side I have a 2 plus, on the other side I have 3 plus minus a 1, so 3 minus 1 gives me a 2 plus. The charges on both sides are balanced now. Let's take a look at the next half reaction. I have cesium 4 plus going to cesium 3 plus. My cesium is becoming less positive, which means it's gaining electrons, and it's only gaining one electron. When you gain electrons, those are going to appear on the reactant side. And once you write the electron in, make sure that you go back and double check the charges. I have 3 plus on this side. I have 4 minus 1. That's a 3 plus, so 3 plus here, 3 plus here, I'm balanced. And now I can add both reactions together, and anything that appears on either side of these arrows, exactly the same, I can cancel out. I have one electron here, and then across the arrows I have one electron, so these electrons can cancel out, and then I can add all of these. So I have iron 2 plus cesium 4 plus. Then I don't have anything else to write. That gives me iron 3 plus cesium 3 plus. And that reaction is balanced. Let's take a look at the second example. I have copper plus 1 plus iron solid giving me iron 3 plus copper solid. Anything that appears in its elemental form, the way it appears in the periodic table, is going to have a neutral charge, a charge of 0. Let's take a look at the copper first. I have copper from plus 1 going to copper 0. Now my copper is becoming less positive from a plus 1 to a 0. It's gaining electrons because it's becoming less positive. It's gaining negative charge. And it's only gaining one electron because it's going from a plus 1 to a 0. And we said when you gain electrons, they appear on the reactant side. So if I write plus an electron over here, I have to go back and make sure that my charges are equal on both sides. Here I have a 0, here I have a minus 1 plus a 1. This gives me a charge of 0 on both sides, and I've written the electron in the correct spot. Let's take a look at the iron then. So I have iron going from iron 0 to iron 3 plus. Okay. I have iron going from 0 to a 3 plus, which means that the iron is actually becoming more positive, which means it's losing electrons. if it loses electrons, and how many it loses, it goes from 0 to 3, which means it loses 3 electrons. And I can write them on the product side if they're losing the electrons. Now let's take a look at the charges on both sides. I have 0 here, 3 plus 3 minus, so 1 minus for each electron, but I have 3 of those, so 3 minus plus 3 gives me a 0 charge over here. Okay, now I can add up these reactions together and then cancel everything that appears exactly the same. Well, I can look at this reaction and see, well, this electron over here is an electron like this one, but I have 3 of them here and only 1 here, which means that I need to make this equal. I need to make this 3 that it appears exactly the same as this one. But if I make this a 3, I have to change the molar coefficients of the whole reaction. So I have to multiply the whole reaction by 3, which means that I have 3 coppers, 3 electrons, so 3 copper plus ones, 3 electrons, and 3 copper 0. Now I can go ahead and I can add these 2 reactions together. These electrons are going to cancel with these electrons because they appear exactly the same way on both sides of the arrow. 3 electrons on the left side, 3 electrons on the right side. And now I add up the rest. I have 3 copper plus iron solid, giving me 3 copper solids plus 1 iron 3 plus. And now this reaction is balanced. It's balanced with the type of ions. It's also balanced with the charges, or it should be. Here I have a 3 plus on this side, and I have 3 times plus 1 of 3 plus on this side. Where if we looked over here, we had a plus 1 and a plus 3. This was not actually balanced. Okay, I am going to stop here, erase, and we will do one more example.